In this video, we will see how to find mean and variance from probability density function of a discrete random variable or a continuous random variable. To understand this video properly, I suggest you to watch my earlier videos on probability distribution and mathematical expectation, whose links I have given in the description box. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. We know mean x bar is expectation of x, which is summation pi xi, where pi is the probability and xi is the frequency of probability. We can find expectation of square of random variable as summation pi xi square. Variance of random variable x is mean or expectation x minus mean of x whole square, which is expectation of random variable minus its expectation ex, which stands for x bar whole square. Expanding, we get expectation of x square minus 2x into ex plus square of ex. This will be e of x square minus 2 e of this x into ex plus ex whole square. So we get variance x equals e of x square. This will be minus 2 ex whole square plus this ex whole square will be minus ex whole square. So we got this formula for variance x, ex square minus ex whole square. We will find mean and variance for discrete probability distribution. For random variable x, corresponding probabilities for discrete random variable x equals x are given as follows. For minus 2, it is 0.2. For minus 1, k. For 0, 0.1. For 1, 2k. For 2, 0.1. For 3, 2k. We have to find value of k, mean and variance. In order to find k, we use sum of probabilities is 1. Therefore, 0.2 plus k plus 0.1 plus 2k plus 0.1 plus 2k equals 1. 5k plus 0.4 is 1. 5k is 1 minus 0.4, 0.6. So k is 0.6 upon 5. K is 6 upon 10 multiplied by 5, 3 upon 25. Now by using the value of k, 3 upon 25, in the probability distribution table, the table will change to, for x equals minus 2, its probability will be 2 upon 10. For minus 1, it is k, that is 3 upon 25. For 0, 1 upon 10. For 1, it is 2k, that will be 6 upon 25. For 2, it is 1 upon 10. And for 3, it is 2k, that will be 6 upon 25. We have mean x bar is expectation of x, which we know is summation pi xi. That will be minus 2 into 2 upon 10 minus 4 upon 10 minus 3 upon 25 plus 0 plus 6 upon 25 plus 2 upon 10 plus 18 upon 25. LCM of 10 and 25 is 50. 50 upon 10 is 5. 5 into minus 4 minus 20. 50 upon 25 2. 2 into minus 3 minus 6 plus 50 upon 25 is 2, 6 2s are 12. 50 upon 10 is 5, 5 2s are 10. 50 upon 25 is 2, 18 2s are 36, which is 32 upon 50, 16 upon 25. So this is mean or expectation EX, 16 upon 25. We have found expectation EX, 16 upon 25. Now we will find expectation of x square, that will be summation pixi square, which is 2 upon 10 multiplied by square of minus 2, 4, plus 3 upon 25 into square of minus 1, 1, plus 0, plus 6 upon 25 multiplied by 1 square 1, plus 1 upon 10 square of 2, 4, plus 6 upon 25 multiplied by square of 3, 9. So it will be 8 upon 10, 3 upon 25, 6 upon 25 plus 4 upon 10, 54 upon 25. LCM of 25 and 10 is 50. 50 upon 10 is 5. 5 8s are 40 plus 2 3s are 6 plus 2 6s are 12 plus 5 4s are 20 plus 54 multiplied by 2, 104, which will be 182 upon 50, which is 91 upon 25. So this is expectation x square, 91 upon 25. We have found expectation of x square equals 91 upon 25. We have variance x equals expectation of x square minus square of expectation of x. So that will be 91 upon 25 minus 16 upon 25 square will be 256 upon 625. LCM of 25 and 625 is 625. 625 upon 25 is 25. 25 multiplied by 91, 2275 minus 256. So variance x will be 2019 upon 625. So we have mean 16 upon 25 and variance 2019 upon 625. In the second example, discrete random variable x and corresponding probabilities of x are given as follows. When x is 0, probability is k minus 6 upon 5. For x equals 10, it is 2 upon k. X equals 15, it is 14 upon 5k. We have to find the distribution function capital Fx, about which you will find in my video on distribution function, and expectation of distribution Ex. First we will find k. For that we will use sum of probabilities is 1. So k minus 6 upon 5, 2 upon k plus 14 upon 5k is 1. LCM of 5k and 5k is 5k. 5k upon 5 is k. So k into k minus 6. 5k upon k is 5 plus 5 2s are 10 plus 14 equals 1. K square minus 6k plus 24 equals 5k. K square minus 11k plus 24 equals 0. K minus 8 into k minus 3 equals 0. So k is 8 or 3. But if k is 3, 3 minus 6 will be minus 3 upon 5, which is negative, and since probability is never negative, we have to reject k equals 3. So k is 8. Now for k equals 8, probability density function will be 8 minus 6 upon 5, 2 upon 5. 2 upon 8 is 1 upon 4. 14 upon 5k will be 14 upon 40, 7 upon 20. Distribution function capital Fx will be cumulative probabilities. So for random variable 0, it will be 2 upon 5. For 10, it is 2 upon 5 plus 1 upon 4, 13 upon 20, and 13 upon 20 plus 7 upon 20, 20 upon 20, which is 1. Now expectation Ex is summation pixi, which is 2 upon 5 into 0 plus 1 upon 4 into 10 plus 7 upon 20 into 15, which is 0 plus 10 upon 4 plus 105 upon 20, which is 50 plus 105, 155 upon 20. So expectation x is 31 upon 4. Now let us see how to find mean and variance of continuous probability distribution. It is given that a continuous random variable x has the PDF probability density function defined as fx equals a plus bx, where x lies between 0 and 1. We are given mean to be 1 upon 3. We have to find a and b. Now, since fx is a probability distribution, we have integral fx dx from minus infinity to plus infinity equals 1. To understand this, I suggest you to watch my videos on probability distributions, the links of which I have given in the description box. That will be integral from 0 to 1, which is the domain, a plus bx dx equals 1. It will be ax plus b x square upon 2 from 0 to 1 equals 1, which will be a into 1 a plus b into 1 square upon 2, that will be b upon 2 equals 1. Now the mean is given to be 1 upon 3, and we have mean for continuous random variable integral from 0 to 1 of x into fx dx equals 1 upon 3, which will be x into a plus bx dx equals 1 upon 3. Integral ax plus bx square dx equals 1 upon 3 from 0 to 1. After taking integral, ax square upon 2 plus bx cube upon 3 from 0 to 1 equals 1 upon 3. A upon 2 into 1 square will be a upon 2 plus b upon 3 into 1 cube will be b upon 3, which equals 1 upon 3. Multiplying throughout by 6, which is the LCM of 2 and 3, we get 3a plus 2b equals 2. Now a plus b upon 2 equals 1 will become 2a plus b equals 2, and this equation 3a plus 2b equals 2. For solving this equation, we will multiply this equation 1 by 2. So it will be 4a plus 2b equals 4, and this equation 3a plus 2b equals 2. Subtracting second equation from the first one, 4a minus 3a will be a, 2b minus 2b will be 0, so a will be 4 minus 2, that is 2. So we got the first value, a equals 2. Substituting value of a in this equation, it will be 2 plus b upon 2 equals 1. b upon 2 will be 1 minus 2 minus 1, so b will be minus 2. So here we get value of b minus 2. Now this probability density function fx will become 2 minus 2x, where x lies between 0 and 1. Distribution function of a random variable x is given as capital Fx equals 1 minus 1 plus x into e raised to minus x, where x is non-negative. We have to find mean and variance. We can find probability density function by differentiating probability distribution capital Fx. You will learn about this in my earlier videos on distribution function, whose links I have given in the description box. So probability density function fx will be d by dx of 1 minus 1 plus x into e raised to minus x, which is derivative of 1 0 minus by product rule between 1 plus x and e raised to minus x, 1 plus x into minus e raised to minus x plus e raised to minus x into derivative of 1 is 0, derivative of x is 1, which is minus into minus plus e raised to x into 1 plus x minus 1. So probability density function fx will be x e raised to minus x. Now for a continuous distribution function, mean x bar is integral x into fx dx from 0 to infinity, which we also call expectation x, which will be integral x into x square into e raised to minus x dx from 0 to infinity. We have to solve it by integration by parts. So mean x bar will be continuous integration of x square into e raised to minus x will be x square into integration of e raised to minus x minus e raised to minus x minus derivative of x square 2x into integration of minus e raised to minus x e raised to minus x plus derivative of 2x is 2 into integration of e raised to minus x is minus e raised to minus x from 0 to infinity. This will be when we substitute x equals the higher limit infinity. Each of these terms will be 0 because 1 upon e raised to infinity, that is 1 upon infinity, will be 0, minus when we substitute x equals the lower limit 0, first two terms will be 0. In the third term it will be minus 2 e raised to 0, which is 1. Therefore mean x bar will be minus into minus, that is plus 2. So we got expectation ex, which is same as this mean or x bar 2. For finding variance, we shall need expectation x square. That will be integral from 0 to infinity of x square into fx dx, which will be this x square into this x e raised to minus x. So x square into x will be x cube e raised to minus x dx. Now by continuous integration by parts, it will be x cube into integration of e raised to minus x minus e raised to minus x minus derivative of x cube 3x square into integration of minus e raised to minus x e raised to minus x plus derivative of 3x square 6x into integration of e raised to minus x minus e raised to minus x minus derivative of 6x 6 into integration of minus e raised to minus x e raised to minus x from 0 to infinity. When we substitute x equals this higher limit infinity, each of these terms becomes 0, minus when we substitute x equals the lower limit 0, first three terms become 0. Only the last term becomes minus 6 upon e raised to 0, which is minus 6 upon 1 minus 6. So expectation of x square becomes this minus into minus plus 6. Now variance x is expectation of x square minus expectation of x whole square. 6 minus this 2 square 4, which is 2. So therefore variance x is 2. So we got both the answers. Mean is 2 and variance is also 2. In the next question, x is a continuous random variable with probability density function given by fx equals k times x minus x cube for domain x between 0 and 1 and fx is 0 otherwise. We have to find k, mean and variance. For finding k, we will write integral k times x minus x cube dx from domain 0 to 1 equals 1. After solving this integral, as usual, we will get k equals 4. Next, for finding mean x bar or expectation x, we write integral x into fx dx from domain 0 to 1, which will be integral x into value of k 4 into x minus x cube dx from 0 to 1, which after solving gives us 8 upon 15. Third, first we find expectation x square, which will be integral x into x fx dx from 0 to 1, which is x square into 4 times x minus x cube dx from 0 to 1, which after solving as usual gives us 1 upon 3. Now we have variance x equals expectation x square minus expectation x whole square. 1 upon 3 minus 8 upon 15 square. 1 upon 3 minus 64 upon 225, which will be 33 upon 225. So variance x will be 0.1467. So the three answers, k is 4, mean is 8 upon 15, and variance 0.1467. Next example is similar to the earlier one. Here also we have to find value of k if function fx, which is kx square into 1 minus x cube for domain x between 0 and 1, and it is 0 otherwise. This function is a probability density function, and therefore we have to find number 1 probability when x is between 0 and half, number 2 mean, number 3 variance. As usual, since given function is a probability density function, we have k x square 1 minus x cube dx from domain 0 to 1 equals 1, which after solving by usual method gives us k equals 6. Now for finding probability when x is between 0 and half, we write k, which is 6, integral x square minus x raised to 5 dx from domain 0 to half, which by solving further gives us 15 upon 64. Now mean x bar, which is also expectation x, is integral x fx dx from 0 to 1, which is k, which is 6, integral x into x square into 1 minus x cube dx after solving gives us 9 upon 14. For finding variance, we shall need expectation x square, that will be integral x square fx dx from 0 to 1, which will be 6 integral x square into 1 minus x cube dx from 0 to 1, which after solving further gives us 9 upon 20. Now variance x is expectation x square minus square of expectation x, which will be 9 upon 20 minus 9 upon 14 square, which will be 9 upon 20 minus 81 upon 196, which after solving gives us 9 upon 245. So we have k equals 6. Probability of x between 0 and half is 15 upon 64, mean 9 upon 14, and variance 9 upon 245. If you like this video, please like it, share it, and subscribe to this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.